So, okay, so yeah, I guess what we're like, it's Tuesday, is that right? Wow, I feel like it should be further along the week, but it's not. All right, so the last couple times we basically went through Capstone overview and stuff like that. Hopefully, at this point, you guys kind of get a good idea of like what to expect and kind of the pacing for your Capstone, right? I just want to ask, like, is there any questions? And if there's ever like, let's say a week from now, like, Victor, like, I thought I knew it, but like, I kind of confused a little bit. Definitely, like, we can start off there and talk because that's the important part for you to make sure you know what you're doing, right? But you guys feeling pretty good about like understanding the pacing of Capstone, what your goal is, what the expectations are up until September 4th, which is like essentially the last that you would do your assessment. Sound pretty good?
Can you
Go,
do
Erica.
like a quick overview, like a 5,000 foot view?
Yeah, yeah. So kind of like I'm just like saying like what are we doing for the Capstone?
Yeah, just a week by week. Just
Yeah. So ultimately, like your capstone's going to be like kind of like a little bit bigger than a module project, essentially. Um, and when I say a little bit bigger, don't feel like it's like super big, right? Like it's not a thesis. It's not like something completely new that no one's ever seen. That's not the expectation. It's something that you can show to an employer, it can show to a recruiter to say, hey, like I took this project from the beginning to the end and started with a business problem, collected a data set, explored it, found it basically found inference, and that usually is in the lines of using a machine learning model, and then actually having at the end of it saying why this is important to these stakeholders. That's kind of your capstone. So breakdown of like week per week. Um, and maybe I'll put out a little bit of a timeline, like a straight up timeline on the Slack. So maybe that might be useful for you guys too. But basically, is that your first step is just, hey, figure out your business problem and get a data set. And the reason why I put those two together is just because of the nature of how quickly we go through Capstone. You should have a business problem, but your business problem is really great, but you have no data for it. That's going to take a long time. So a good idea is to look at a business problem, maybe brainstorm a couple of them, like it's things that you're interested in, see what data sets, are available for that, and kind of think about like what it would take for your business problem. And then that's like your first step is just getting the data set. That should be done this week. Um, Technically, I put August 17th, which is next Monday, as your due date. But ideally, I want you guys to like get that something to me by this Friday. That way, you guys can dive right into it. Make sense so far? Okay, cool. And when I say get a data set, like at least explore it a little bit, like, download it, look like what's in it first. That's going to be kind of an important aspect because otherwise I'll be like, oh, cool, what's in your data set? And you say, I don't know, looked cool though. So make sure you kind of do that part. But you should send that to me. Either you could honestly just put it on the Slack if you guys just want to, if you guys are open to sharing with everyone, just like say, hey, this is my business problem. Here's my data set. Hey, Victor, can you check it out? Or you can DM me directly. Okay. That's first step. Next step after that is doing your EDA, like a little bit more than like a basic EDA. And I mean, like just going through saying like how many data points you have, kind of saying like what the variety is in there. Is this going to be sufficient for your problem? Do you need to get more data? So like it's at this point you should have already been approved, but now you're thinking about like, okay, I need to explore this data. And this one, like I will like ask like, hey, like as you go through it, just kind of like check in with me. Like you might have a one-on-one with me and I might just ask you during that one-on-one. But if I don't have a one-on-one with you for whatever reason during the week, um, I might come after you and just say, hey, like how's it going with everything? Or like just send me a message one day and say, hey, like this is what I have so far. If you've been doing frequent Git commits, real quick thumbs up if you've been doing Git commits frequently. Like instead of just like do the whole project and then one commit. Okay, good, perfect. Maybe somewhat. All right. I am someone who's like, I'd rather have someone commit frequently, where it's like almost annoying, where it's like every line, versus like having just one commit because then you can see the progress. So an easy way to do this is like if you just start a repo now, for your capstone, whatever it is, and just add stuff to there. Don't add your data. One thing, make sure you don't add your actual data just because it can take up a lot of room, but add it on there and then do your commits. And then like when you get through your EDA, say, hey, you can just send this out either to Slack to everyone or me and say, hey, like, how does this look? And just to make sure you're on the right progress. And so that should take into next week. Like I'm thinking like if you get your data set figured out and done tomorrow, like, oh, I know what my problem is. I know what my data set is tomorrow. Like you could be done with the EDA before like Wednesday next week. Make sense? Cool. All right. And then once you have that, that basically, all right, you you should have enough exploration to kind of answer, like get an idea of like what questions you can answer, and then say, okay, now I have enough like understanding of this data to go into modeling, right? Which is like your feature engineering, your modeling, and then into analysis. And that should take you, in my opinion, that modeling section, just because probably people I'm guessing are just not haven't used a whole lot of different machine learning algorithms like over a long period of time. That might take you some time, but I think the big part's going to be the analysis of understanding what does your machine learning model mean if you're using machine, like I should say, if you're focusing on machine learning model, which most people are. But the main thing, your analysis at the end of that is like, hey, how do their models do? You know, is this a viable, you know, thing we should actually use in certain circumstances, or are there better ways? What things can we do? Other inference about that data set and that business problem. And that should take probably about, I would say about a week and a half. And that should take you basically, like by the time you get to your analysis, your conclusion section is going to be like, oh, you already know everything because like you got it all figured out. And hopefully at that point, then everything feels pretty smooth. Like I feel like once you get like halfway through analysis, you kind of already know like how your whole project's going to turn out. Okay. Okay. And does that kind of help, Erica? Like just like timeline and stuff like that?
Yeah, that was really good. Thank you.
Okay, no problem. And of course, if anyone like ever gets confused about timeline, like feel free to like, you know, ask on Slack, right? Ask during these kind of times, you know, I'll feel free to talk about that. And I'll try to go put a little rough timeline like I had last time. I'll put that on like Slack or something, just so you guys can have like a little checklist. So helps you kind of stay where you need to be, right? Cool. All right. So yeah, sounds pretty good. Yeah. All right. So I'm going to go ahead and share my screen and we'll start talking about that doc. And it's good. There's a few questions on there. So, and I'll just kind of go down in order there. There we go. So all my windows are going to move around. Okay. And of course, as I'm going through this, if you're like, ooh, like I have a follow-up question or that, or like, you know, something along the lines, yeah, feel free to interrupt me too. And like, you know, we can either go off on a tangent or, you know, we can kind of add that onto this list, right? So what I kind of do, I didn't talk about this last time, I put the old questions down here. If I answer them like kind of in line here, or if anyone wants to type in like a little like a tabbed answer in there, you can, and then I'll just kind of keep in there. That way you guys can reference back to it too. If you guys ever like, oh, what did they talk about? So anyway, all right. So how can you convert black and white photos to color in Python? Ooh, really interesting. So this has a few heavy, well, okay. First of all, if it's a black and white photo and you're trying to convert it to color, that might not work, just because in the sense that like if it is literally black and white and there's no color information, like how are you going to get color out of that? Of course, like I should say is that if you're talking about like, oh, can we do this with deep learning? Yes, people definitely have done this. If you, I'm pretty sure if you like search Reddit, like I see it every once in a while where someone uses deep learning to like basically try to recolorize black and white photos. That's an option. I don't think that's what the question is asking. I'm not sure who asked this question, but I don't think that's what's being asked. Erica, is that you? Or I saw a little hand or someone move a hand? No?
Yeah,
Okay.
screen switch, but yes, that's me.
Okay.
And yeah, that's what I meant. Recolorize
Okay.
it.
Cool. Because I was like, there's a couple things, like a really easy way to colorize photo. That's basically black and white grayscale. It's just say, oh, just add a red channel. And now I was like, oh, look, my photo is red now, which is probably not what the intent was here, like you said. Yes, so this is a really interesting area of like definitely of research right now. I'm trying to think from what you guys have knowledge wise. Like I'll be frank, I haven't done this specifically, and I haven't looked a huge amount into like what this would take. Ideally, with most like, you know, deep learning, like I'm assuming this would be more of a deep learning project, just because of the complexity of it. So if you approach any problem for machine learning, really, not just deep learning, you always have essentially an inputs and outputs, right? And basically your model takes in your input and tries to match it with these outputs. And then once you have enough training from that, you have new inputs that it doesn't have an output for, or at least not that it's going to see, like maybe use it for testing. But you take that and you input that into your machine learning model that's already been trained, and it'll output something that hopefully is what the thing you want. So in this case, what you could have essentially like is a very like vague in that sense of like what exactly you do, but you'd have an input of saying, okay, here are photos that are black and white. And then at the end output, it's like, here are photos that have color on it, right? And so basically the idea would be to train it so it knows these are black and white photos, figure out how to change these weights and biases and stuff, assuming a neural network, and output a colorized photo. And then you would take a black and white photo that it hasn't trained on, put that through that same network, and have it basically produce, also produce a colored photo. Does that make sense? Okay, and that like process is very like general, right? Like that's true for pretty much any problem that anyone is going to do for with a neural network. Now, the key part is saying, what's the difference between a black and white photo versus a colored photo, right? And let's assume like you can get like a colored photo and then you can get a black and white photo version of it, which you can, but let's just go with that, right? It's like a grayscale or black and white. Okay. How do you convert this grayscale photo into, like, what's the difference between those two? Does anyone know? Like for images? At least like digitally, I should like, obviously like they look different, right? Yeah, so, okay. Oh, sorry. Who said that?
Yeah, so like the rank of the tensors for black and white, you're only going to have like one channel, like you said earlier. But for color, you're going to have three. You're going to have your RGB channels.
That's right, yeah. So you're talking about the rank of the tensor. If everyone's familiar with rank, basically it's like how many dimensions the tensor has, essentially. And black and white grayscale photo is a 2D array, basically how, like the values of each pixel, usually 0 to 255. But there's just one channel to talk about it. So basically it's just one 2D matrix, right? A tensor. And then having a colorized photo, you would have multiple channels, we call it. You know, it would be like was mentioned, it's going to be a higher rank. It's going to have other dimensions, basically 2D slices. So you're going to have usually like red RGB, red, green, blue. That's usually kind of like what we talk about. There's other options too, but we'll talk about red, green, blue. You'll have a red channel, a blue channel, and a green channel. So in this case, what you probably would have is like, all right, I like this is, if I were going to approach this problem, right? And let me ask you guys, like, how would you approach this problem? Like, let's say you have some photos, right? They're all different sizes and such. Like you have now, like, okay, we have a colorized photo. How would you get, you think, a grayscale photo from a colorized photo?
In the image data generator, could you just set those settings to grayscale to?
Yeah, that's definitely like the easiest way. It's like, oh, use a library to make into grayscale, right? Which equivalent just going to average out all the channels. So like if you have red, green, blue channels and you average out the channels, you'll now get like one number for those three numbers for each pixel, right? And technically, I guess it's a pixel for each channel. I don't know how computers work, but anyway, you would have like one channel. So that you could say, okay, they convert to grayscale, and eventually you'll have like, let's say your photo is 100 by 100 pixels, right? You'd have 100 by 100 pixels for red, 100 by 100 for green, 100 by for blue, so three different channels. You would then get like use some kind of tool to convert it over to grayscale, right, to 100, right? And you could possibly say, okay, now go ahead and taking like and realize to this grayscale image has less information than the red, green, blue, right? So the idea there is that you're going to try to train the neural network to learn how to essentially create information from it. And so your input, let's say you just do your input's going to basically be 100 by 100 picture, and your output's going to basically be 3 times that size. And my guess is that a vanilla neural network that you guys have been using before with like Keras and TensorFlow might not be enough. And so there might be some other techniques and stuff, but the good news is that I know people are doing this and I know there's research on it. I've definitely seen the research, I just haven't like read anything into it. So you would probably want to look and say, hey, like, what are people doing? The base one you could probably do is like, hey, like, how would I, like, how do you say this? The big problem, not the big problem, but the big thing at the end is like, okay, cool. Like, let's say we can get like, put our black and white photo 100 by 100. So like, what's that? 10,000 inputs, right? And it'll come out to 3 times that, 3,000 or 30,000? Sorry. Yeah, 10,000 to like 30,000 outputs, right? The thing about the outputs is like you have to have a way to say, how close are you, neural network? Like, how close did you get? And so that might be challenging. There's a few ways you could probably do this. The really simple way, but just to say, hey, for each pixel, how close were you? But my guess is that that's probably not going to be the best way. And there's probably going to research to say what would make the most sense for this kind of situation. So I don't know if that kind of gives you some ideas, Erica, or if you've already been kind of thinking about this a little bit on this kind of project. But my suggestion, if you want to go in this direction, is that, hey, go look up, just literally look up, deep learning, black and white photos to color, and just see what kind of pops out. You can honestly Google this to kind of get in a start of like seeing what's already done, what seems reasonable versus like just kind of match your expectations of what people have done already. So know like you're probably not going to do any better than that necessarily. Like you could, but like maybe not, right? And then you guys know Google Scholar, right? Like it's like Google search engine for like basically more academic papers. That might be a good place to start, just to kind of like see what's up there. Just know that those research papers might be more heavy on the math. So just kind of know that like, and this goes for anyone if you guys searching for this stuff, for papers for like neural networks and stuff, it might be heavier in the math. So just kind of know is that yeah, depending how familiar you are, it might take a little bit more time to go through it, or it might feel like, just if you're not familiar with math, it might just feel like, I don't know what's going on. But it might give you an idea at least of like reading it through, like understanding what's going on. Because there's some really advanced techniques. And I'm guessing is that because this is not a really, I'm assuming it's not a really easy problem. One way to start is starting off with like very low resolution pictures. Like I'm thinking like almost like 30 pixels by 30 pixels. And outputting then, like starting with a color picture, getting grayscale, and seeing if you can go basically backwards. So yeah. Does that answer, Erica, like kind of lines? Since you asked the question.
Yeah, that gives me some places to, some things to think about and how to structure my search for it. So,
Yeah, cool. It definitely sounds like a really cool problem. So, yeah. And hopefully that kind of helped you guys too, even if you're not necessarily doing the same thing, you get the idea of like what kind of process you might look at, right? Any more questions, either from Erica or anyone else about anything related to this or anything I talked about on this?
Probably gonna have to have something pretty strong to do like a bigger picture, right? So you might have to have like some kind of AWS support.
Yeah, I would suggest for this capstone of the proof of concept, start with small first. And then just to make, because the worst thing I would say for you guys, for any of these projects, is that if you start off too big, you might not be able to, like, the infrastructure might be the thing that keeps you back versus doing the cool data science stuff itself. Now, this is where, like, do you guys know MVP, most viable product? This is kind of more of a software thing, but it also goes for like data science, machine learning. Basically, it's like you don't want, like, ideally what you want to do is getting something that kind of works versus trying to work all this time to make it work perfectly. You want something that's going to do like the basic stuff at least, so then you have something to show for it. And then say, okay, well, can we improve on this basic stuff to make it more enhanced so it does, the thing that you really want it to do. So that's kind of like what I say for this project, is making sure you have something that is like, feels reasonable, like a 30 by 30 like picture on a neural network. You could probably you could probably do this on your own computer, at least at some level, or at worst you can do it on like Google Colab, which is free. Like mentioned AWS, right? So you can use like an AWS thing or GCP and stuff like that. But like once you start going deeper into AWS and GCP and like trying to make sure this runs, I worry about like how much time it takes for you to make sure that works versus doing the stuff that's really the more data science focused stuff. But if you do go that route and you feel comfortable with it, like there's no issue doing that too. But start smaller is my suggestion. Even if you want to like maybe like say, okay, like I want a more higher resolution picture. Don't start with like a 4K picture and like trying to like scale it through, because guaranteed like that's gonna be that's gonna take up a lot of power on AWS and stuff, or whatever you use. Okay. But good point, Blake, that you could probably like use something like using cloud infrastructure to train your stuff. Cool. All right, can we move on to the next question then? Sound pretty good? All right, cool. So, all right, I want to center my capstone on preventing AI bias. What's a good place to start? Okay, so yeah, this is an interesting one. So AI bias, right? So how familiar are we with AI bias? I'm assuming the person who asked the question probably knows. All right, so Erica, okay, cool. Maybe it was you again. Okay, cool. So AI bias, right? Well, how about Erica? Like, do you want to get into detail, like what you mean by this, and like what you'd like to explore?
Yeah, so there's man, there's different types that I know of. The challenge is, well, what can I actually do something about? But just to give you guys some background, for instance, with Facebook and targeted ads, certain demographics get certain ads and certain pieces of information, and others don't, so to speak. And even if we go to the realm of facial recognition, I don't know if you guys are aware of this, but like 2 to 3 years ago, Google Photos had this huge faux pas because they were um, categorizing Black people as gorillas. It's not funny, but it's just, wow, how do you even, you know? So that's on a level. And then more so professionally with LinkedIn, there are some recruiters that have only have access to a certain demographic of candidate. So that's just an example of that.
Yeah, thanks, Erica. Yeah, there's a whole bunch of issues with AI bias, and like you said, there's definitely some ones that stand out. Like you mentioned, Google Photos, like which I don't. Is everyone familiar with Google Photos? Like what that is? So basically, I saw a head shake. So Google Photos basically you can upload your photos like you're like up on a consumer level, right? So oh, you can upload your photos as a backup thing, but it does some extra stuff where it does some like kind of machine learning. Whereas like for example, I use Google Photos a lot for the record, like I'll put in like dog on grass and I'll pull up like my dogs that are on grass, like just by searching for it. And so I never labeled it, this is a dog, this has grass on it, but it's kind of does some machine learning in there. So Erica mentioned that there was a few years ago an issue where basically certain people, like some people would type in gorilla and some of their pictures would show up and it's like hey, like I am definitely not a gorilla, and it definitely tended towards people who had darker skin, right? So unfortunately, the fix of this, I don't know, Erica, if you're familiar with what they fixed with. You couldn't search for gorilla. Basically, it didn't work anymore. Like, which is kind of like, in my opinion, like I guess that's like at least you're getting rid of the harm, but not really a solution. So there's a bunch of reasons why this kind of bias happens in here. Where, like, for example, why was it so bad at? Why was it making such bad mistakes for people with darker skin versus, maybe the rest of the population? And part of this comes from the fact that a lot of it is just the data that is given to it. Like you only like a machine learning algorithm doesn't really know what things are. It just knows these are patterns, and when I see these patterns, these are what's happened. So you guys know the MNIST, like the little numbers and like little grayscale numbers they use for image recognition. You guys know what I'm talking about when I say that? Um,
Oh, that, yes. It sounded
yes,
different.
this guy. Sorry, did I say the wrong? I might have said the wrong letters in the wrong order. But like these numbers, you guys have seen this like picture at least a couple times. Yeah. So this classic one, like you can take a neural network and have it train to learn what, like, oh, this is a 5, this is a 1. But of course they're different. Like if you look at the pictures, right, they're different like shapes and stuff like this. Well, the fun thing is this actually has bias in it. Like in bias, not the like racial bias and stuff like this, but just bias that it's only seen 0, 1, 2, 3, 4, 5, 6, 7, 9. It's never seen something essentially that's not a number. So really fun stuff you can do with this is that you can give a bunch of static, basically like a bunch of jumbled up pixels, and it will confidently say, hey, like, I'm just giving an example, but it could actually do this. It confidently say, hey, I'm like 90% sure that's a number 2. And like, you're like, what? Like, what do you mean that's a number 2? It looks nothing like a number 2, but it's just looking for patterns that it saw over and over again that determined that this was number 2. So a big thing in AI, and like you say AI, ML, is really the data stuff, the stuff you feed into it. If it doesn't see examples that you try feeding into it, it's going to make mistakes. And that's what we're seeing a lot of, in AI bias, basically, is that a lot of the data coming in it's not complete, and usually complete is like one thing's like, oh, for example, like if you're doing self-driving cars, how often do people run in front of a car, like, try to run in front of a car? Not super frequently, but because of that, there's not much data on it. So that means if someone does run into front of a car, like, the machine learning algorithm potentially just never seen that situation and might make mistakes. So there's a whole bunch of ways bias can come into this. And that's where I say, like, bias can be not just like, even just like racial, but like just general, like, oh, it's never seen this thing. However, the reason why it's a big deal is when it starts becoming where certain groups are biased against it because there's not examples of this. And that we could go on and on with about like different examples of this because it's like everywhere. So this would be an interesting one. This is definitely a big area of research. Like, how do you prevent this? You could have a capstone, Erica, or anyone who's interested in this kind of thing. You could have something where it kind of explores how much bias is in these, like maybe a machine learning algorithm that you develop or a machine learning algorithm that other people have used or something like that that's available to you. So one example of this is like the one that comes to my mind constantly is like natural language processing, because that's something you can get like a huge amount of data for. You can see, like, you can start building up metrics of saying like, okay, like, let me take this groups, like, let's say for example, taking groups of people who like talk a lot on the internet with each other, like, different demographics, different, like segments of the population that might not be represented in this, model and stuff like that, and see basically where it makes mistakes and see how like it changes the sentiment and stuff like this. This, honestly, it's a really cool project. I might guess it'd be a lot more exploration, right? And saying like, hey, like, let me test this out. Like, you'd be really focusing on that analysis versus building up the model. But because of that, I would kind of worry that this might end up taking too much time. Just like in the sense of like, this might be like a really great project that you could do over like a few months because you can explore different models and stuff like this. I would suggest though, if you do want to go in this way for the capstone, and you're saying like, hey, exploring might be a good idea, like, kind of exploring what bias exists already in a system, is find some kind of architecture that already exists that you can test out. And using that architecture, can you find different like let's say different segments of whatever you want to do to expose or test for bias. And you would have to build up a metric to say, like, this is why I'm kind of approaching it, is figuring out a metric of like, how can you quantify how much bias is in a system. And there's definitely research on this, but it might be an interesting way to kind of like start from scratch and say, okay, how would I define bias and how would I identify this in a machine learning algorithm? And so like the applications would be really great, right? Because you can say whatever you end up using it for, let's say you only use it for NLP, let's say you only use it for prediction, basically whatever you end up using it for, right? It could even be like for classification. Anyway, so like all these different things, and say, okay, like, how can this be useful for future models and stuff? That might be an interesting way to do this problem. Yeah, I don't know. Any thoughts, any ideas? I don't know. What's a good place to start? Yeah, it's a whole lot going on in there for sure. And I will tell you, there is like an area like AI ethics. Yeah, Erica, go ahead.
Ooh. No, I was just gonna say, like, I've just been taking notes as you're talking. So, yeah, you gave me a lot of things. AI ethics.
Yes, like that is a big thing that I think doesn't get talked about as like, it's not as like cool and sexy as like, deep neural networks and stuff like that. But I think it's a really important aspect of understanding what harm can be done from like AI. Seems like whenever I say AI, part of me kind of cringes a little bit just because AI here is like the business person, like saying we're going to use AI, and it's just like, oh, it's a linear regression, like, kind of like that kind of stuff, which happens a lot. But it's like, if you look up AI ethics, that would be a big one. There is a book in particular, which I think is a really great one, that if you guys haven't read, Weapons of Math Destruction. Has anyone heard of this book? No? Okay. Math Destruction, there we go. Yeah, this book right here. It is a really great book. Like, it talks a lot about like the biases that are in, like, basically let's talk about math, but like more focused essentially, like, you hear algorithms and stuff like this. This is really data science, like big data algorithms. And so this is beyond even just like neural networks and stuff. And this is like, I think it's a really interesting book. It's not going to be as like it's going to be more accessible to people who don't necessarily have a machine learning or data science background. But I think it's a good book just kind of like to read about like the issues and social impact of like what can happen when basically algorithms, AI, and stuff like this have biases baked into it. One last example I will tell you, like just because I want everyone kind of be aware of these kind of things, is that it doesn't just have to be like image recognition and natural language, because people usually go like, oh, well, yeah, because you know people talk, people look different, you know, stuff like that. Like that's why there's issues. It's like, oh, it's just complicated data. That's the real problem. But this also is true for denying people services and stuff like this. So recent example is with the Apple credit card that came out. Was it last year? I think it was last year. And they had like an automatic approval process and like what your credit limit was. And basically there were a couple stories, but one in particular, especially one from a data scientist, basically was like, hey, I got a credit, I'm making up these numbers, I don't know. I got credit approved for $10,000 on my credit card. But my wife, who should have the same exact credit history as me, and like they even went deeper into it just to make sure, and like they did, got like a credit limit of like $200. And they're like, what's this huge difference from? And basically when they called up Apple and said, hey, like what's up with this? And basically people kind of ended up like the story ended up being that the people kind of giving information is like, well, that's the algorithm gave. And that's a really dangerous part. It was like, hey, that's just what the algorithm gave, but they're not really sure what happened to it. And that's kind of the issues of like, you know, why bias is such a big deal. Because it's like, if there is a bias built into the machine learning algorithm, you have to learn how to identify it first. And then two, be able to say, well, okay, like, why is it doing this? And how can we prevent it? And it's kind of a big deal, especially as we have like more and more, you know, this stuff being determined, you know, like if your loan application or, you know, like if you're trying to buy a house, like if these things become more and more automatic and there's bias built into it, this can be an issue. So anyway, this is like, again, like, like this area, like AI bias, AI ethics, like is a huge like area for sure. And I'll tell you that if anyone is ever interested in going in this direction, they like as you might expect, they're pretty open to having people come in, and it's pretty cool. So anyway, great. There's a whole bunch of places you could start, Erica, if you want to go into this or anyone else. But definitely message me if you find something or you like go a direction and stuff, and maybe we can help that because that'd be pretty cool. Cool. Any follow-up on that one, or should I move on to the next question? Yeah. Okay. All right. Cool. So I know, Jari, you had this question. So about generative deep learning, we kind of talked about it before I started the recording. And you were saying like you're just interested in generative deep learning, right?
Well, I wanted to try and generate some art with GAN. So I'm kind of, that's like, I'm pretty sure that's what I want to do. So like almost 100%. So yeah.
Yeah. So, okay. So we kind of talked so I'm guessing you're a little somewhat familiar with that, like what can be done with like generative, you know, deep learning and stuff like this.
Yeah.
Yeah. Cool. And that's good. And is everyone familiar with like generative, like learning stuff? Oh, this is some, man, this is the stuff that's going to blow your guys' mind when you find out about it. So one of my favorites, so basically the idea of generative learning is that you can train a neural network and basically say, hey, like, this is an example of a bunch of things. Now make this thing. And so, for example, this website, which has improved over, you know, the past few, like couple years now, is this person does not exist. This is not a picture of a real person. This is not a picture of someone who, like, they took a picture of someone and they modified it. This is completely built up from scratch, essentially. And so think pixel by pixel kind of deal. And so if you look, I mean, I think I saw some jaws drop a little bit. This is like, oh, like, I don't think, like, if I saw this, I don't think I would have immediately say, oh, that's a generated person. I'm starting to do that kind of stuff now just because, like, I see so many online now. But, like, for example, this is how I can tell, like, this is how my tells is usually by the hair and stuff, like outlines. You can see it kind of gets a little, like, I don't know if you guys can see this over Zoom even. See, this is the thing too. It's like once the resolution kind of gets dropped down, there's kind of like these kind of fuzz, and like you can see it has trouble with its outline. You can also see like the reflections on his glasses aren't quite right. But my favorite thing that's recent that happened, like it used to be, you could tell he's wearing sunglasses, so you can't really tell. But like you used to tell because the eye color would be different. And it's because when you generate these things, it tends about really focus, like local area. And so it would tend to make, like not make mistakes, but like wouldn't remember that it had eye color blue over here and then made it brown over here. But in recent, iteration stuff, people kind of figured this out. So you can see eye color matches a lot better and stuff like this. And you could just do this all day, like generate stuff like this. And one of the other ones it tended to do, you can see kind of like this mistake on the outline stuff. Man, these are way too good now. It's weird to see this evolve over time. If you look at old stuff like this, like the old models, it's pretty cool. So sometimes you'll see, there it is, their earrings and stuff will tend to mess up too. So kind of like similar with the eye color, but like these eye colors, like this gets me. Like this is past like few years stuff. There's also like, here's my favorite. This cat does not exist. So it generates pictures of cats. So basically it was showing a lot of pictures of cats and said, generated pictures of cats. And you can see some interesting ones, but you can see some really weird stuff. So this is obviously trying to make a person with the cat, but like it has some weird makeups and like messes up. So anyway, generative learning can do some really kind of cool stuff. It definitely, like Jari was saying, is like very artful in a lot of ways. I think like it's some pretty cool stuff. You see, oh, there's some messes up. So anyway, stuff you can do for hours stuff. Yeah.
Have you seen the AI generated art that was like sold at the auction for like $500,000? The portrait of Edmund.
I don't think I did. No.
It's called Portrait of Edmund. Yeah, the second one. Yeah, Edmund.
Oh, the second one.
Yeah. So this was the first AI generated art that was sold in this like really prestigious auction in London, and it sold for like $432,000.
Interesting.
Yeah, it's really interesting. You should look into it. Like they kind of like not stole the algorithm, but like not algorithm, but like they copied a lot of code, and it's just like it's really crazy and interesting. But it's cool that people are interested in that and that we study this. So I thought I'd give it a try.
Yeah, no, that's really cool. Hey, maybe you can make some money off of this. It'd be pretty cool. The fun thing about this stuff too is you can generate stuff like crazy, right? Like, it's interesting. It's an interesting idea as well. Like that, what makes, like, especially in the art world, like what makes good art in a lot of ways. Like how do you define this as well? But yeah, you could have some fun with this. Cool. Have you guys heard of DeepMind? Oh my gosh, it's like Deep Dream. It's been so long now. It's like old news now. Like, was this back in like 2015? Yeah, 2015. So Deep Dream, have you guys seen these pictures before? Yeah, okay, see some those. So this is not exactly a GAN, like, which is what most of these generated, like the most like, what do I say, like state of the art stuff. But this stuff actually uses convolutional neural nets. And what they did basically is that, you know how convolutional neural nets have different layers, and each of those layers detect new patterns? You guys learned about that with CNNs? Okay, so the idea with Deep Dream is basically you say, hey, like here's a pre-trained neural network. Now take a photo, and using this filter, essentially, I should say filter, but this segment of the neural network, what do you like, what triggers your activations? Like, what part of the photos really like say, oh, this is really important? Because like maybe, for example, the algorithm is designed to find like eyes, for example, like that part of the neural network, right, is used to find eyes, and like that's where the activations get higher. And so some parts of the photo are going to have more activations on like, oh, this is more eye-like than this part. So like obviously circles will tend to be more eye-like versus like flat planes or something like that. And then you say, okay, those are your different activations. Now, and change the picture to maximize that value and just reiterate over and over and over again. So they call it Deep Dream because it was done basically, it's kind of like the concept of like, oh, like the computer dreaming. Basically, it's like kind of like looking up at the clouds and like seeing pictures in the clouds that aren't really there kind of deal, because they kind of look like things. That's kind of the idea of Deep Dream. And this is where like, I think people kind of look at it as like, ooh, like it feels kind of creepy. Like, I don't know, like it's on off. Definitely very artful. There are some reasons why you might care about this stuff. For example, you can do this process, and they do things with algorithms. Like, for example, like, oh, like I've seen a paper that they show like a white screen essentially, and they say like, hey, this is part of the neural network that says this is the thing that defines thing as strong. Like they would have like an image thing go through and say the word strong. It's like, okay, like what made you think strong? And they put it on the image, like basically a blank canvas, and say, like change this picture to be more what emphasizes the strong activation. And what they found was interesting was like, for example, like this one, it's like they found like really like muscular arms, like basically just made muscular arms, and that was what it defined as strong. But you can find certain things like this, like there can be issues, for example, like in your neural network that you have, let's say you have your neural network and you learn it, teach it to like detect cancer, right? And or skin cancer, that's a classic one. So you have like skin cancer, like different, like, oh, is it malignant? Is it benign? And you have this different classification based on the images. And let's just pretend you really messed up. And when you got this data in there, all the like malignant cancers, like your, like, I don't know, I'm not a doctor. So like whatever like skin pattern on these like things that are potentially like skin cancer, you, every time like it was like, oh, it definitely is cancer, you have like yellow tape around it to like say, oh, this is the area. And those were the only pictures that had yellow tape in there. Well, what you'll find is that probably the validation, like, wow, validation set, it's doing great. Like it is like almost 100% super accurate. The thing is though, what you might find is that it's actually not looking at the picture now of like, of like the skin cancer, like potential skin cancer, like on the skin. It's actually looking at the yellow part. And it's just saying whenever there's yellow in the picture, that means it's skin cancer. And so what's nice that some of this stuff you can actually use to, hey, like, what is the thing that's activating this part of the neural network to make this like become a thing? Like basically activate, say, oh, it's this thing or that thing or whatnot. So there's some use in this and stuff, but I'll be honest, most of it's going to be art because it's just fun to look at and stuff like that. Now I did mention, like, I think in the question too, there was about like how could you make it more businessy, business-like, right? So one thing you can use with GANs, and this used to be done a lot more with autoencoders, but autoencoders are like old news in a lot of ways. Like now it's like, oh, everything's about GANs, which is GAN is a generative adversarial neural network. So there you go, this guy right here. So this is kind of like more of the state of art stuff. You can use this to help generate data. And turns out generating data can be a really big, important pre-processing step. Oh yeah, go ahead.
What do you mean by generating data, and like what, like in what, like, I guess, way?
Yeah, so this is actually, that's a really good question. So sometimes like we see like this person does not exist, and you're like, oh, like that's just what that's just fun, right? There's not like, maybe you can generate people's faces, like oh, this can be useful. But when I talk about generating data, it can also be for some really simple stuff. And like I say simple, like not pictures essentially. And so you can imagine I have data that like this is like real life data, and I have data like on a 2D plot. And like, there's like some kind of data points like this. Okay. And I say machine learning algorithm predict these points, right? Well, you guys probably know if you do this well, the machine learning algorithm will learn something that looks like this, right? It's like, oh, that's my model. Basically, we'll come up with the equation for this. Well, the problem is now say, okay, based on your model now, can you like generate some data so that we can like, for example, let's say you only have like 100 points and you have this model that's made from it now. It's like, hey, it'd be useful now to like make more points so then we can do our testing and stuff like this. The problem is if you say, hey, generate like from the model, can you go ahead and create more data points so we can actually test around with this? The problem is that this model in general is just going to end up essentially like almost in a sense overfitting, and it'll make too perfect of data. Does that make sense? Like, so this is actually like a big part of like when you're trying to generate data, like why we want this. I mentioned before the recording started, Uber's advanced technology group, ATG, does the self-driving cars, and a big portion of like their stuff is trying to figure out how do we generate data. And the reason why is because there's always going to be so many examples that you're just not accounting for. Kind of similar to like AI bias. It's like, hey, like, you know, for example, I mentioned it before the recording, like imagine like you want to make sure your self-driving car looks out for people just like jumping in front of cars. But like, how often does that happen when they're like driving around their self-driving car to collect data? How often does that really happen? It's like not super frequently, you know? And so you'd want to be able to like generate this data, say, well, what does the situation look like to a car? So that way it can protect it. The problem is though, is if you literally had one example, let's say you like were able to like by pure chance, someone jumped in front of the car, you were able to brake in time. And so you had one example of this. Well, the problem is now is that if you just like copied that and just had it train that same example over and over again, it's going to overfit. It's going to have that bias basically of only seeing that one example. So you'd actually want to generate data to say, hey, like, I don't want this situation exactly, but I want something like this situation. In the same way you wouldn't say like, I want a person's face, but I don't want the same face that I've shown you before or any of the faces I've shown you before. I really want an idea of a face, but without literally giving you, without like reusing a face that was already seen. Does that make sense? Like where that use case comes from. And again, this is where like bias can be really like, it's a really interesting area because like if you can generate something that is essentially, it's not the thing you like trained off of, but it's got the idea of what this thing is and it's different, then it's like, you can then use that as kind of extra training for another neural network to train on top of that. Does that make sense? I know it's kind of a little subtle point, but that's kind of like where like GANs and like generative data can be really useful as a pre-processing step. And so what you might have to begin with, let's say you have only a few data points, you know, like let's say you have like 100. 100 is probably not going to do super well on a lot of deep learning algorithms, right? But if you can use some pre-processing step to basically generate now to like, you know, maybe like 1 million data points from this 100, say, hey, these 100 data points are examples of what I want you to have. And then say, all right, now generate 1 million data points that are not exactly like this, but have like the concept of this, which is essentially, this is the model. This is like the 100 points. And then generating would be something that's like this model, but not literally the model. Does that make sense? Okay. Give me a thumbs up if that explanation actually like made sense or not, like for anyone. Thumbs down if it's like, I don't understand. Okay, I see a thumbs up from Erica. At least one person maybe. So did that answer your question too, Jari? Sorry.
Definitely,
Yeah.
definitely.
Cool. Yeah, there's definitely some interesting things you can do with this. But this is why like a lot of the papers you'll see like for generative like GANs, for example, are just saying like, how good can we make this? And that's why, for example, this is there's actually a really great YouTube channel that that talks about this. Have anyone heard like 2-minute papers? Okay. They're never 2 minutes long for the record. But they do a lot of, he does a lot of like talks about, he basically just finds different papers that are on, usually he's more visual focused. So I know he just recently got his PhD in like computer vision or something computer vision related. And he basically just takes papers and just talks about it. But you can see here, like, can AI learn lip reading, AR effects? So he does a lot of visualization. I know for sure he does, let's see here. He's talked about a few GANs and stuff. And so this, for example, style 2 GAN. So you guys can see that video real quickly. So like you can, if you watch like this video, for example, you could probably learn a little bit, but this is kind of fun. So this right here, I'm trying to remember if it's this one. Oh, here. So what's kind of cool is like, how does this work? This is actually on a vector space. And so what you can do basically is you can move the vector across the vector space, because like you guys learned about embeddings from like NLP and stuff like this, like word embeddings, things like that. So that's kind of the idea what's going on here is that you can move this vector within the embedded space. And as long as you're moving in that vector, it's going to be a smooth transition because it's multidimensional, but it's still smooth. And so you can actually get this change, like, let's see if he actually does it. There we go. So like they're actually moving that vector and stuff like that. So it's still generating a new face, but it looks like it's still in that local area. So it's relatively close and stuff like this. I think you can see some interesting stuff. There's another one that I saw he had recently talked about. Maybe this is the one, but there's some interesting applications. For example, like, well, what if I want, for example, like these are the initial photos right here, like the kind of the starting off point. So can you generate data off of this? And so this bottom one right here, I'm just turning off these captions. You can see this bottom one. Oops, there it goes. That's better. So this bottom one right here is basically the thing that's kind of, I think this is the generated part. This is kind of like moving in the vector space. And this is kind of like saying, but make it look like this photo, but take this into account. And you can see how it transitions as it moves to the vector space, how this as well as changes. And it's interesting too, is like you can see the complexion change, but you can see essences of the other one and such, which is really interesting. Like that you, like this is, be fair, StyleGAN 2 is relatively recent and stuff. This is kind of like more state-of-the-art stuff. But this gives you an idea of like what you can do with it and how good this can really get. I don't know if that kind of, I don't know. I actually don't even remember what I was going to specifically about, but give you some examples of like GANs and stuff like that. Okay. That gave you some ideas, Jari?
Yes. Could I just ask one more quick question?
Yeah.
I guess what are jobs in this realm of like generate? Because I know the Uber thing. That's very interesting. I didn't even know, like, because I guess you do generate quote unquote data with like your art, but I didn't know people would then turn around and use that in order to, you know, train other stuff. But at any rate, what are jobs that like would be interested in this project, I guess?
Yeah, so I will tell you the most interesting fringe stuff is going to be research focused jobs, right? Like jobs are like their job is data science researcher, which for the record, if that is a direction like anyone's interested in, like more schooling is always going to be better. And it just honestly in academia, like it's kind of like biased towards that, where like they kind of only consider that, but there's a lot of like research stuff. Maybe it's something to think about more in the long term, like maybe kind of go in there. But I will say is that there are definitely jobs in the sense of like, I would say if you're interested, like, hey, like I want to do some really cool stuff, like this kind of thing that can still be useful. My suggestion is if that's what your goal is, look for startups that have kind of like this idea of like, you know, usually they're using more like technology that's like, hey, like it might not be useful immediately, but it eventually will be. Or really big companies like honestly like Google, like Facebook, like those companies that can spend a lot of money on kind of essentially doing research and doing some real cool stuff before it becomes like actually like applicable in any way. That'd be kind of like my things, like if you're kind of looking like, oh, I really like this idea here. But I will say is that this by itself can actually be really useful in outside of just like being like oh, we're studying generative learning and stuff like this. Honestly, the best way to do this is kind of look at and talk to other data scientists in the field that are in that job and say, hey, like, tell me what's the a really easy one to kind of like say like, hey, what's going on in the company is you ask someone, say, hey, like you're doing this stuff at this company. Tell me about the coolest thing you're doing right now. And you can hear it because it's either, oh, we're doing this thing and it sounds like, wow, that sounds really dry and boring. Or like, it's like, oh, like, you know, you can hear people get excited. Like, oh, we're doing this thing. Like we're using recurrent neural networks to decide, you know, like whether a customer should go in this direction or this direction. And I remember talking to someone about this and they said like, oh, we're doing like recurrent neural networks. And I'm like, oh, interesting. Like that is not something like typically done in marketing and stuff like that. Like you can tell, like, even though like might sound like, oh, like at its face, like, oh, you're doing everything like everyone else, they're applying a different kind of process, which can be really interesting and engaging for you as you as an employee can be really engaged in that aspect. I can't say specifically like, just because like, I mean, generative like GANs have been like in the past like 2 at the earliest 3 years really been developed. So like you can kind of get an idea of like only 2 years of kind of development is kind of tough to be like what specifically you can get a job into that, because it's just like always evolving. But I can say is that it can be really applicable to the job that you're in. Along those lines, again, I'm no expert to in the actual like full industry of all the different things. Like someone might be able to actually find something or talk to people. So that's why talking to people who are in the field right now in industry and say, hey, tell me about something you're doing right now, can be really helpful for you to understand, like, hey, should I pursue this, or what can I pursue? And usually people are pretty good at being open to that. Yeah.
Find these people though. I'm hard pressed to find
Yeah.
people who know what a GAN is.
Yeah. So, okay. So this is an interesting part, and this is definitely something maybe we can talk. I know we're kind of like low on time. Maybe we can talk about this tomorrow. It's no problem. Actually, I think I have one with Payson, but he's in here, so I'm gonna assume that he's okay with making it a little bit longer or extended. But what was I gonna say? So okay. So one thing you can do is first like find those groups of people, and I actually one place I really like to go to find data scientists is actually Twitter. And I know people have different experiences with Twitter, and they can be very hostile at times, but I do find the data science community is pretty active and pretty like welcoming to people in that area. So going through Twitter and just finding, like, literally finding, like, what I honestly would do is like, hey, like, for example, I have to think about how to have this saved. There it is. So this book right here, Hands-on Machine Learning with Sensor, Scikit-learn and TensorFlow. Has anyone gotten this book or heard about this book before? Okay, see, I see some nods, I see some shakes. This book, in my opinion, I'm like, I suggest this to every person who's going in data science, and that includes people who are first starting off to the point where people are like, no algorithms, but they're like, how do I apply this stuff? This book, in my opinion, is like amazing. Like, it's great for like saying what is like real applications, and like saying how do we do this. This whole book, also for the record, if you don't get the second edition, if possible, the first edition is great, but the second edition has even more, including GANs and stuff like that. It also has TensorFlow too. But this author, what I was trying to get at is like, this is a really great book. And I'm like, wow, like when I read this, I'm like, this is a really great book that really explains, like, in my opinion, right, does a really great job of explaining a whole bunch of stuff. So that's one thing I suggest this guy with you guys. For you guys.
Scikit-learn guy, right? Like, he's one of the founders.
Not this person. So there's also I think
or something.
what was that? Say
The
again?
data camp or something. I thought he was like connected with.
You know, I could be wrong.
I could be too, but I thought.
Yeah, I could be wrong with that. I don't think he is. I know he used to work with YouTube, Google, one of those two. This is why he actually knows probably a lot of people in the field and stuff like this. He's probably been kind of hopping around a little bit. I can never pronounce his name. Like, I've heard him say his name a few times, but I can never pronounce it. I'm sure you guys would have better luck with it. But I wanted to say, like, this is a great book. And there's also, there is GitHub. He has his GitHub page right here that has like literally like his lessons from the book. For the record, I still suggest getting the book. Like, you can read this stuff, but you will see that this is what's it called? This is not like, it's not sufficient. Like, you can go through this and you can run the code, but like understanding what's going on, it's really useful to have the book. But like, there's some great code here for you to kind of understand stuff, and you can see he talks about all this stuff in the books, in his book. But what I was getting at is like, okay, this is a really great book. What I would do is like, hey, if you find something with a great resource like this, and then literally just like look for this person, online. I personally like looking people like on Twitter and seeing what conversations they have. And like, what's kind of nice about Twitter is that you can see the interaction between different people. And so you can kind of see that kind of like community kind of build up and stuff like this. And once you kind of get an idea of like where this, what's it called? Like, who's out there, you know, you can kind of get ideas like, okay, like these are people I can pursue and stuff like this. And this is where, like, if you find them like on Twitter or like, you know, I think between Twitter and LinkedIn are two great ways to interact with people. A lot of authors for a lot of these books and stuff like this, or people in the data science community, will interact with Twitter. So if you like, you know, direct message them or just kind of like tag them and stuff like that, a lot of times, you know, they'll be happy to talk with you, stuff like this. LinkedIn is the same way. If you are going through LinkedIn, I would suggest, you know, because it's kind of a hit or miss, I think sometimes because people just get spammed with LinkedIn constantly. Definitely do not just like connect with a person. This is a nice suggestion for you guys. Don't just connect. Definitely take some time to like write out that little like note when you connect. You know what I'm talking about when you do LinkedIn? You can write like a little note when you first like connect with them. Say like, hey, I'm a student, like I I found you from this, or I saw some stuff that you did. This is really interesting. I'd love to talk to you more, or like, I'd love to get your advice, or I just want to, connect with you or whatnot. You can kind of phrase this however you want. But I would say in general, like that is a better way to connect to someone. Like I unfortunately get like, and I'm not someone like an author in any way like this of like a really great book. But like even I get like message like connections from like LinkedIn, and I'm like, it's like I'll just get a connection and I'm like, I don't know who you are. Like you seem like a nice enough person, but like they just said a connection, and like I'm just like, I don't know. Like I have like 20 different like requests over some time, and I'm like, I don't know who you are. Maybe I'll bump into you in a second, and if I don't bump into them or interact with them the next week, I kind of just like deny the request, unfortunately. Like I don't know, maybe I'm not the nicest person, but that's kind of like ideas like where you have someone who's a little more involved. I'm sure they get kind of spammed a lot with LinkedIn, so just kind of like if you want to make that connection, maybe start off, like my suggestion is almost like maybe start off with Twitter first. If they have a Twitter and they seem active on there, like say direct message them, say, hey, things really cool, and then if they're responding back to you, maybe connect them on LinkedIn. So that can be really useful, and just talk to people. And I think that's just the easiest way. Like I don't know. I'm not someone personally who's like really big on like social interaction of like, oh, let me make like, how do you networking, right? So people talk about networking. When I hear networking, it makes me like cringe a little bit. Not because it's bad, but just because like it feels very like artificial, fake, if that makes sense. But that's not really what networking is, and that's something I've learned recently. Like I've learned over the past like few years that like, oh, networking doesn't necessarily mean like, oh, you're just trying to get something from someone. It really can be like, hey, like let me talk to this person and like get your advice and like interactions like that, and maybe you meet up later on in the future. That'd be kind of, I guess, a way like kind of going back like, how do you find people? It's like find resources and such, like blogs or books and stuff like that. Find those people, maybe interact with them if you can. Or also see like who do they follow, like who are they interacting with and stuff like that, or like who in this space is kind of there, and you can kind of talk. And you would be like, I will say in general is that like maybe it's a little bit of a bias in the sense because I haven't had really bad interactions, but I feel like the data science community in particular is much more open than a lot of other computer focused communities. So sometimes the computer science community can be a little rough and kind of I don't know how to explain it, but like maybe not like necessarily the most welcoming group sometime. Same thing can happen with machine learning. I do find the data science group tend to be a lot more open stuff. There's still issues, like there's definitely people you're going to find who are jerks or all that stuff, but I do tend to see that the data science community tends to be a little more welcoming for especially new people coming in. So maybe we could have a whole talk about this too. Maybe we'll talk about it tomorrow. But yeah, that's kind of give you an idea, Jari and everyone. Yeah, cool. All right. So this book though, I would highly recommend this book. It's got great stuff. For my lessons and stuff like that, I'll sometimes even use some of the code in here. I'll directly reference it and stuff, but it's just like, I'm like, this is a great application stuff. Cool. All right, so I guess I will end it here unless you guys have any other questions or comments you guys want to do before we head out.
This isn't, you can end the recording, but I'm just saying I got this generative deep learning book by O'Reilly, and I think that'll probably be good too. So
yeah, I think that's really good, especially if you know a specific part of like machine learning or data science that you want to look at. Like, explore that. I haven't read that specifically, but I have heard good things about that book in particular. This one, the book that I just showed you with hands-on machine learning, the super long title, that does a really great job of just like talking about a whole bunch of algorithms, and also like how does this work practically, like not just the theory. Like I think he does a good job of like not doing too much theory, in my opinion, which sometimes feels unnecessary and sometimes much more geared towards academics, versus like actually being useful, like, and say actually useful, being like useful like in the job, and giving like that practical knowledge. It's like, oh, this is what code you can use. So for example, he has this great section talks about activation functions, like about like for neural networks, and basically like he does exactly what you want at the end. It's like, hey, what activation should I use? And basically has a quick summary, like this is what kind of like the overall idea, like what you should look at. So that's the kind of reason why I kind of bring that book up, is that I think it's a great one to see how you can apply it. But if you want to go a specific one, I think that's where you might want to go deeper into the theory, where you're like, hey, let me learn about that specific thing. But that's why I suggest this book a lot, because I think it works well for anyone who, whether you're kind of already in data science or in machine learning, or you're just starting off.